Okay, for recording number 2, you're going to need to turn your books to page 518. We're going to talk here about a procedure called sensitization. Sensitization is a process where if something bad has happened in your life and then there's one simple little stimulus there, you could react in a really violent way to that new stimulus being presented. And so they wanted to, once again, in the field of cognitive neuroscience, kind of map that idea. So maybe as a first thing, you want to kind of type out a definition of what sensitization is and use your book and the other information in there to get that information down. What they basically did is they worked with sea slugs. And this is sea slugs are called aplysia. So let me give you the setup. Figure 14.12 will be the key one here. So in sensitization, if you look at figure 14.12, let me kind of give you the situation at hand here. If you actually take a sea slug and you just give a little weak touch to its mantle shelf, you'll actually find that there's something called a gill withdrawal reflex. And if you just touch the mantle shelf a little bit, you'll basically see just a little bit of a gill response reflex. Very small, almost minor in that particular way. So that is stage 1. You just give a weak touch to the mantle shelf. You'll basically see almost no gill withdrawal response. Phase 2. In phase 2 of the method, you take something a little different. You go to the tail, and to the tail you deliver a sharp electrical shock. So if you go to the aplysia and you give a sharp electrical sorry about that, getting tongue-tied with my words. You give a electrical shock to the tail, you'll basically see that there'll be a strong gill withdrawal reflex. So that would make sense. A sharp shock leads to a strong gill withdrawal reflex. Then what's very interesting after that is that if you take that sharp shock going on and at the same time you actually do that little weak touch to the mantle shelf, if you kind of pair those up, so in one situation, and how many times am I going to say this to get myself tongue-tied? In situation number 1, you give the sharp electrical shock, and then at the same time you give a little touch to the mantle shelf, and that's going on. What you'll basically find in the last phase of the experiment, in the last phase, they'll actually go back to this mantle shelf and just do the weak touch again. But what's really interesting is when you do the weak touch after pairing up this with the electrical shock to the tail, is you'll actually find if you just do the little weak touch to the mantle shelf, you'll actually find a really vigorous gill withdrawal reflex. So this is once again the idea of classical conditioning. And what a cognitive neuroscientist wants to figure out about this, they want to know, okay, so what's going on there? Why is it that you can just touch something real gently, the mantle shelf, and then just get a weak response in the first phase, but then after you pair it up with a electrical shock to the tail, why does now a weak touch to the mantle shelf cause such a vigorous response? And what the neuroscientists have been able to figure out is, if you look at that picture there are a lot of drawings and a lot of different things going on, but there's what we call a facilitating interneuron. And so the idea is, and I'm not going to go into that much detail here, if you look at the connections in the mantle shelf, you'll see that the mantle shelf has a neuron that goes all the way to the motor neuron that causes the gill withdrawal to happen. And there's actually a neuron kind of coming from the electrical shock, a facilitating interneuron. And if you pair the two up, the facilitating interneuron causes that mantle shelf neuron to release more serotonin. And because it causes that mantle shelf neuron to release more serotonin, you basically get more of a gill withdrawal reflex. So the idea here is they've been able to trace neurobiologically the exact neurons that are actually at work here causing just a minor touch to the mantle shelf to have a major gill withdrawal reflex. They've actually been able to link up and study the neurons that actually do it. So this is once again the field of cognitive neuroscience, because what we're basically doing here is we're seeing a behavioral phenomenon. Sensitization. We've always known that exists in classical conditioning, But what we're doing here is we're tracing the neurobiological pathways. We're saying, okay, we got this learning occurring here. Learning and memory are part of the cognitive field. What's going on in the brain? What's going on? And we can take a little sea slug here. We can say, oh, look, there's some neurons overlapping here causing this response to occur. So this is the field of cognitive neuroscience. Example number 2. Thanks. Bye-bye.